So now I'm recording, hopefully. All right, so we're going to ease into programming today with two examples, kind of like I promised. And I'm not even going to give you any homework on these yet, just so that we just kind of get an easy start. That way, if your other classes are making you start hard, you can't blame me because I started you too hard in the first of the semester. So we're going to talk about how to create arrays so that you can size them dynamically. And all that means is that we're going to create a pointer to an array and then work with that. And then we're going to refresh our memories on class templates. And I'll show you an example. And also give us a chance just to refresh some of our object-oriented stuff about how we're going to define classes and stuff like that. You'll see. So let's start with dynamic memory. So the idea is that we want to be able to create an array of a specific size because you have to. Arrays can only be a certain size. And then if we use up all that space, be able to reallocate it so that we have more space. And that's exactly how the vector class works behind the scenes. You don't see it because it's all part of the implementation. But the vector is actually storing its data in an array. And then when you fill up the vector to its capacity, then it auto-magically doubles the space. So like if you start out with, I can't even remember. Let's say you start out with 2. Once you fill up that second element, then on the third pushback, it will double that to 4. Then when you fill up the 4 elements, then it will double that to 8, and then on and on and on and on and on. Okay.
So it's like doing conditional checking. Once like size gets to capacity, double memory.
Right. And here's how it does that. Okay, so let's look. So the first thing we're going to do is we're going to create a simple little array. And I'll even use an initialization list to allocate it. Again, this is not refresh. This is not just to refresh your memory of things, but also in case. Well, you're going to be doing it in a class. I'm not here to keep it simple. Okay, I keep it simple. I want you to see I want to keep it simple, but I also don't want to just give it all away. Okay. Oh, absolutely. You don't need a class to do that. Now, when we starting next week, we're going to implement our own vector class, and of course, we'll put it in a class. But this code will look almost like this anyway. It'll be within a class definition. All right. So anyway, I'm declaring a pointer array nums, and I'm allocating 5 integers, the space for 5 integers. All right, so that's what new's doing. So new int 5. 5 means 5 spaces, and I just went ahead to save time because we don't care about that, and initialized it to 5 spaces. I mean 5 numbers, 1 through 5. All right. And then we can use, so let's say, and if it started out, we could also have started it out like this. Well, never mind. I'm going to save that for a minute. So, oops. Okay. All right. So now let's say that pretend like we used up all that space, and we're like, oh crap, now we need. Oh darn. now, sorry, I'm not used to speaking in public. We need to double the size, or we need to increase the size. Well, the way we're going to do that is, first thing we're going to do is we're going to create a temporary array that does not have to be a pointer, okay? We're creating this pointer, we're creating nums as a pointer array so that we can delete it, but then reallocate it without having to redeclare it from scratch, okay? But the temporary array is just simply a placeholder to store the array data until we're done reallocating. Okay, so then we're going to write a loop. And I'm using hard coding instead of like a variable for the size of the array, but do as I say, not as I do. So Normally we do. Normally I would use variables there or constants, for the size or something. All right, so the next step after I declare my temporary array, of course, is to copy the elements out of nums, out of our pointer array, into the temporary array, okay, so that I've preserved that data, okay. The next step then is to delete the data that's in nums, okay. So remember, can you read that comment? Okay. See, I need to change my color. I can read it, but just barely. It's a light gray on my screen. I'm not sure what it looks like on there. Anyway, all right. So when we write delete, open, close, square bracket, nums, we're taking back that memory that we created. So again, to refresh your memory, there's two types of memory that we use in a compiler, the stack and the heap. When you declare a variable int num equals 1 or int x equals 1, that's stack memory. The compiler uses the stack. When you use pointers and you allocate space for a variable or an array, that's on a different reserved set of memory called the heap. Okay, and there's other names for it also. That's just that's how I learned it 1,000 years ago. So that's what I call it: heap and stack. All right. So now all we have to do, so we've created our pointer array, we put some data in it, we created our temp array, we copied the data from the pointer array to the temp array, we've deallocated. All right, so we'll also call that deallocation. And remember, we have to do this. Well, in this case, because we're going to resize the array, but also just in general, when you use pointers, when you're done with whatever you're using, you need to delete it so that you reclaim that memory. Otherwise, you're going to have what's called a memory leak, and you can essentially crash your program at some point because you use up all the memory that there is. All right. Anyway, now we can reallocate nums to a new size, and then we're going to initialize nums to the default type for its data type by using the open close curly braces. I think I showed you this last semester. Okay. The compiler sees this and goes and looks at this and says, okay, that means that the default value for the type. So the default value for int is 0. So just to demonstrate, this is not part of the. So we're taking a side trip here. Okay. Okay. So there's nums reallocated with the default type for int, which is 0, which is what you want to do, okay? Just to be on the safe side, because what we're going to do is we're only going to fill up the first 5 positions because we've only got 5 numbers here, okay? If we didn't do that, well, I'll tell you what, let's do it correctly, then we'll go back and see what it does if we didn't initialize those values. I think you can probably guess. Now we're going to copy the data from temp back into nums. So that's what we're doing here. And then we will write it out again. And actually, I'm going to delete this. Where'd it go? I don't need that now. I'll tell you, I'll just comment it out. so that I have a record. Okay. All right. So this step, we copy what's in temp back into nums, and then we're going to just, for display purposes, display what's in nums now after we copied data back from temp. So you see the original data. I always want to be looking on the screen instead when I know that it's on here, but I'm super tracking. I do that when I'm up here too. Anyway, so there's the original data, and then there's the five, what, 6, 7, or 5, 6, 7, 8, 9, the elements left that haven't had data put into them yet. Okay. Now, if we don't, let's see what happens if we don't initialize nums to default value for the type. And it may still work. Nope. So, I mean, that just goes back to the old rule in C++. You always need to initialize memory before you use it for something. Okay. Just like, if you tried to add two variables together, and one variable was initialized and the other one wasn't, what did you get? Some sort of junk number there, right? And that's what we're getting here. This is just whatever random data was stored. And it's funny that there's a couple of actual zeros. You think, oh, it's looking good, but then you see these, you're like, oh crap, no, it's not. All right. But the simple solution to that is just to initialize with the open close curly braces. And that's a fairly new feature in C++. That's only been around since like C++ 11. Now we're on I guess we're on C++ 24 or 23. I don't know. I've kind of lost track of all the updates. I need to see what the most current version is. But so anyway, so you couldn't do this before. And just as an aside, and this is what I thought we talked about before, you can do that anytime. So even with just a plain old vanilla variable, you can initialize it. And is that better than this? For my computer science 1 students, I'd say no, because they wouldn't know what the heck that's doing, what this is doing, and I want them to get accustomed to writing everything out, right? Before you can use the shortcuts, you have to know what the rules are, right? I don't know that that's necessarily true, but that's that's what they tell you. Before you start breaking the rules when driving, you gotta know how to drive, properly first. Then you start breaking the rules, right? Speeding, running. In my neighborhood, it's running stop signs and stop lights. That's what happens in my neighborhood the most. Anyway, all right. Yeah, that bothers. Yeah. So speaking of that, I hear that there was a bad wreck on the interstate this morning that held up traffic all over town. Well, supposedly I don't know, something happened. My wife is trying to drive. We live in North Little Rock, and it took her almost an hour to get across the Broadway Bridge to Little Rock. Yeah. And then she was like, I don't know what's wrong because I don't see any wrecks. And I didn't either. And then I looked on Facebook and someone was on the interstate saying, okay, this is, Yeah, they're saying that, people were getting off the interstate and so clogging up all the side roads and everything. Anyway. All right, so that's how you do it. So what we'll do next week when we implement our vector class is we will use this very scheme. Okay, so that, and we'll before we actually start the implementation, we'll look through the vector class and we'll look and see exactly how it allocates memory. And we can do that. We can do that because we can. I'm not going to show you now. I'll show you later. Anyway, all right. Any questions about that? And I will post this code after class. All right. Next up, templated classes. Let me comment all this out so we don't have to look at it. Okay. All right. So the other thing that we're going to have to know how to do is the classes that we implement for these data structures have to be able to work with multiple data types. What we don't want to have to do is create a separate class, like so we're implementing vector, okay? We don't have to create a string vector class, an int vector class, a double vector class, a bool vector class, a char vector class, blah, 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 okay? So instead, we use templates as a way to say, okay, we're going to tell the compiler at runtime what the type is going to be for this class, the default data type. And that's not the right word. The data type we're storing for this class, that's probably a better way to say it. And then we'll use that, okay? And so if you remember, the way we do that is we create what's called a template. Now, you might also see, and for classes it may even make more sense, you might also see instead of template type name T in angle brackets, you might also see people that write class name if you're looking at code online or somewhere else, okay? Either way is fine. The quote-unquote experts on templates prefer that you use type name. This is that was left over from a long time ago, but either one's fine. But anyway, so your definition is always going to start out with type name, template, angle bracket, type name T, close bracket. All right. So we're going to create a stack class just because that's what I had the example for, and I didn't want to create anything else. And we're going to come back to stacks again later on in the semester. All right, so I'll assume not too long at all. All right, so we're going to first, what I'm building now is going to be the definition section of the class, in case you've forgotten about that. And we're going to really cheat, and we're going to store our data in a vector just to make it easy, okay? Because I'm not, the point here is not to really create a true implementation of a stack, but to demonstrate how templates work, okay? So any place that requires a data type that's going to reference the type of data that's being stored in the class, we're going to replace that with our type placeholder, which in this case is capital T. And remember that this can be anything. T is just a convention. It's not required. It could be any letter. It could be a variable name. It can be blah, if you want to call it blah. All right. So I'm keeping it simple. So the only piece of private data that we have is going to be the data store. In this case, the vector. Nope, it's not a void. Right. So we have a put. So remember stacks. A stack is a first in, first out data structure that the primary two member functions are push and pop. Push data on the stack, pop data off the stack. Okay, so because we're pushing data onto the stack, we replace for the data type in our definition here, we're going to use T. Okay, and I could go ahead and call it, put the name there, but we'll leave it out. Then we have the pop member function. We'll have a member variable called empty, which will check to see if our stack is empty, because popping an empty stack is an error. And then we also will have a size member variable that will return the number of elements in the stack, which sometimes is considered cheating. in my day as a student, we would not do that. But lots of implementations these days include a size member variable. And there's more that you could add there, but that's enough to start. Okay. So, and I'm only doing this because you need to see how the so this is, I'm sorry, I said this is the definition section. This is the declaration section. Now to see how you do the definition part, it's a little more involved because I have to start every member variable definition with template type name T or whatever it is. All right. So the push member function calls pushback from on the vector to store a piece of data. So notice that there's our template header, for lack of a better term. We have to put the T in angle brackets anytime we reference the class. Okay. So because we're resolving push within the stack class declaration, we have to put stack T first, and then colon push, and then because each item we're pushing on the stack is going to be of whatever we define the type to be at runtime, we have to the data type for the argument is a T. Sorry, haven't lectured in a few months. So I'm having to think about the words that I use. Okay. And every member function is going to be written the same way. So we have to do that again for pop. Yeah, using a vector, you really can cheat well because there's a pop back function in the vector class that you just call directly, which is kind of cool. But again, this is definitely cheating for yeah, I will, because I just realized I left out a higher item, ITEM. I left out the top function, member function. Let me go back. Item is the argument. No, I member with in a declaration. If I have to prove in the parameter list, in the parameter list, all I have to do is put the data type. I could have put item, but you don't have to. All right, but I'm glad you highlighted it, because I realized that I forgot top. So top returns the top element of the stack, and because we're dealing with conceivably complex objects, we want to pass it as a reference. Okay, so that's why it's T, and it could have been like this as well.
Can the ampersand or whatever we're calling that reference sign go before the T?
No. It can either go right after the T or right before, either right after the big T, the capital T, or right before the little T. Okay. Well, it's a reference to the type, but it's it's a reference to the item that's being returned by that function, which is going to return whatever is sitting at the top.
So if it's at top, though, does it like tell the computer to just look at the type on top?
Well, what it's going to do is, all right, look, all right, so all right, no, stop. So watch. All right. I can't. All right. Okay. Now, from here on out, anytime any reference to T is going to be replaced with string. Okay. Now, I think I'm going to change my name. Only because oh no, I'm not. It'll be fine. you know, when we do these little implementations, sometimes it's confusing if you use a name that's also part of like the standard template library. But I think this will work okay. So I almost decided to change it. Then I said, nah. All right. Anyway, so this let's write out the definition, and then I think that'll make it clear to you. All right. I think that's next after push, pop, and top. Yep. Template. But now you can see that this is, you know, as with all object-oriented coding, a lot of typing going on here. You have to put the template thing every single time. And I'm just thinking of stuff that I didn't. This is an old example. I think we could make that a const. Let me compile it. Well, I can't compile it there. I'm gonna do that here too. Hang on. Because we're not changing anything, okay? Remember, oh, I should have been compiling from the very beginning. Okay.
What is just the back part? You just have return data dot back.
Yeah, hang on. Let me fix that. All right, let me look at my definition here. Hang on. Oh yeah, the data type return is this. Duh. All right. Okay. I didn't comment out all the code clearly. So hang on. All right. So back returns the last element in a vector. And again, we're cheating because in real life we'll implement that as an array, and we're going to have to keep track of where the top is. Okay. Because you're going to start out the first element you put in the first element that's popped onto the stack is going to go into array position 0, right? Okay, the top doesn't change really. The top is always 0, right? But then further down, you're going to have the next insertion point is going to be 1. So you're going to have to increment a variable to know that the next element that's pushed onto the stack goes in 1, and then you have to increment that so that the next empty spot is 2. But we'll get to that. And using a vector is cheating because the vector keeps track of a lot of that for you. Which is why vectors are probably pretty good data structures to use instead of arrays for lots of applications. We talked about that. I've talked about that in every class. Even Bjorn Strustrup, the developer of C++, would say, if speed's not an issue, use a vector. Don't use an array. So much more flexible. Okay. All right. So we have a couple more things to implement here. So that was top. And we could stop here and let's do that. Let's play with it a little bit. Tight. So maybe you can't make it a const. All right. I have to think about that some more. And that may not be why it didn't run. But it compiles just fine. And that was it. Couldn't be a const. Okay, fine. All right. Oh, we haven't implemented size yet. So let's see. All right, moving on. Bool stack T. Okay, so again, vector has an empty member function that we can just piggyback right off of. As well as a size member function that we can just piggyback right off of. Okay, so there we go. All right.
Okay. So it binds to the type, not to the name.
Oh yeah, definitely. That bind. What a great programming term. Yeah, it does. That's exactly right. It binds. Yeah. So now I'm just playing to see that some of my stuff works. Yeah. Okay. Whew. Got to make sure that pop works, and we can check to see if our empty member function works by writing a little loop that will tell us whoops. Speaking of bind, where is my problem with top? Cannot bind non-const L value of type bool at. Did I write my code wrong down here somewhere? While not flags.empty, cout flags.top. It's giving me the error when I call top. Now the only thing I can think of is that is pop not working right? No, but it's a compile. I was thinking it's not a runtime error because I can't compile either. But didn't it work before? All right. Do I not call top anywhere in here? Yeah, I call it right there. All right, so hang on. Let's take out the code that seems to be causing the error. Run it again. So top works fine in this scenario. No, that won't work. That won't work. Can't loop. That's the problem with stacks. You can't really loop through them. Let's see if this will work for one pop. Aha. That doesn't really help. Because flags has 3. I mean, what I thought was happening is that it was empty wasn't working correctly and it wasn't recognizing that it was empty. Let's look at pop. Pop just calls pop back. All right, so boy, I just don't like that. All right, so we'll comment it out. Which is weird because whoa.
Really didn't like that one.
Wow.
You probably just have to take out your, at least to see if your vector is working, you probably just have to take out
I'm going to take out the whole class definition.
I was going to say just take out the little bit that you were doing with flags. Now it's not going to compile the computer if you're calling the stack on.
I can comment all that out too.
Because right there you're trying to declare your vector of bool.
Oh, thank you. Yeah. Oh well, I get. Oops. Okay. Yeah, I do understand that error. All right, so. Well, that didn't really help me any. So I'm not gonna belabor it now. I will belabor it in my office on my own. But it's weird that it worked. Oh, yeah, see, it's hard for me to let that go. um, let's bring it back. Let's get rid of all this. Let's start over. Okay, all right, so that's the French version of Scout. All right. Whoa! Did y'all see that? Look at the top. When I only pushed one. All right, so I told you my laptop blue screen had the blue screen of death earlier today.
Okay, so I have in VS Code the exact same code that you do in my work.
So am I finding another problem with code blocks? Which is weird because I've done this for years. And I probably ran that exact code many times. But that it could have very well been in an old. I don't remember when the last time I updated this computer was, to be honest. Updated code blocks. So yeah, that's weird. Well, I'm not going to keep going because these are weird errors that should not be there. But this is the idea, okay? I absolutely did not mean to go off into this tangent on these problems. Yeah. But here's all right, and so what I was going to do, so my idea was, all right, let's get rid of bools because maybe bool's doing some weird stuff with that, and just stick with ints. But now, so let me change that. That is correct. Well, 3 is the top anyway.
That's super weird. I assume that it's code blocks.
I guess. All right. So let's wrap this up and quit worrying about my errors. I'm probably going to go into Visual Studio and do it again just to. I don't want to end the day like this. So I'll go back and check it. All right. So when we create our implementations of these data structures, we need to make them as generic as we can, meaning that we can run them in multiple data types without creating a specific class for each data type. So before templates, if you wanted a stack of integers, you have to create an int stack class. If you wanted a stack of strings, you have to create a string stack class, and so on and so forth, right? Okay. But with templates, that alleviates the need for that, and we can define or to use Timothy's word, we can bind the data type at runtime, which I like that. That's exactly what you're doing. And that way we don't have to define, specific classes for each data type. Okay. So template, type name, whatever is your first line. And then wherever you're referencing the data type of the data that you're storing there. And also remember that if it's the right kind of class, we can have multiple placeholders, type placeholders, okay, if we need to. We probably won't do that very often in this class, but you can. All right. So then, like when I declare my vector, it has to be a vector of type t, so that the t will be filled in when, like down here, when I write stack int, right? The argument for the push member function has to have the t data type. The top function, because it returns data, has to be marked with t. Those are the only two in this particular case. But then every time, in the definition section, every time I have to use the template header, and then I have to reference, because we're resolving this member function to this class, I have to reference the class with t, and then certainly for the argument, because there's an argument, it has to have a data type, it has to be t. There. I don't know why that's driving me crazy. Put it back. And so on. All right. Anybody have any questions? Okay, so no real homework this week. Kind of give you a break before we start the hard stuff. Because starting next week, it's just like nonstop coding until December the 12th.
What are some of the big projects we're doing? I'm not talking about the final two or whatever. But are we making any significant programs?
Probably nothing. Probably not really applications, because the data structures that we're going to get to are so complex that that'll be enough just to implement those. I might give you every once in a while, if there's a data structure that lends itself to some particular algorithm. So for example, with stacks, we might, I might give you a program that has you convert decimal numbers to binary using a stack. There's an algorithm for that. Or I might, that one's not that hard. A harder one would be to write like a program that converts infix arithmetic to postfix. You know what I'm talking about? Can you see the board? So it'd help if you had a marker that worked. I can draw on that at some point, but I'm not sure how to do it. So 1 plus 2 times 3, that would be 1, 2, that would be 1, 2, 3, star plus. Okay? So, boom, 6, 7.
Oh, you're writing like the order of operations?
Yeah, but postfix just makes it, calculators use postfix. Okay? It's also called, is it called Hungarian notation? Which is kind of I don't know. Anyway, that's another application of stacks. We might write our own we can make our own maps using hash functions and a hash table.
Using the map?
Like a map, like a map data structure, key value. Okay, we can write our own, but that's part of. So you implement that and then you use it to do something. So that's the kind of thing that we'll do. But I'm telling you, by the time you get through all the implementations, you'll be happy if I don't give you too many of the other things to do. And it's enough. Okay. My goal is for you to understand how these data structures work because you implemented them. Then you have a complete 100 not 100%, but you have a much better understanding of how maps work if you have to implement one.
I want to make like either a 2D or 3D array, and then put like little elements in there that stands for like a block or something. And say, hey, you get from this point of the array to this point of the array, and do it in the shortest amount of movement.
All right, so that's a graph that we will do. That we will cover that. How to create graphs. Yeah.
The 3D array is a graph.
Well, you don't necessarily implement it as a 3D array, but it's a graph is just like you have a It's like you just have, like, here's Little Rock, here's Fayetteville, here's Jonesboro, here's El Dorado, here's, Camden or whatever, okay? What's the shortest way to get to one thing from somewhere else, okay? It's like boom, 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 whatever, okay? Stuff like that. If you consider that fun. Graphs have limited practical use, but tons of theoretical use. All right. Okay, I'm done. I need to wrap up this recording so I can get it done. And I will be putting some reading things out there when I do. I probably won't this coming week, but after that, it'll be under. I don't know if I have a course resources folder in our shell yet. If I don't, I'll put it there, but I'll let y'all know. Don't worry about it. So for this weekend, just relax.